All right, we're going to talk today about right triangles again, but these are the special right triangles. Like I said, some of the stuff we did yesterday that we used our calculator, set up their proportions, and then use the calculator, that's not going to be on the quiz. It's only going to be if you're given a ratio, so they'll give you two of the sides and you find the other one, or if they give you a picture. In this case, guys, there's something called special right triangles. I know you guys have seen this before. I heard somebody say yesterday, why are we doing geometry? You're going to see the same concepts in pre-cal, in college algebra, in liberal arts math. It's kind of encompassing the same thing. Once you get past algebra 2, you're going to start seeing the same stuff all over again. So you're going to have a little bit of geometry, a little bit of algebra, a little bit of pre-calc stuff in all of those classes. But we're going to talk today about the special right triangles. Special right triangles, there's two different kinds. You guys have heard of a 45, 45, 90. That means one of the angles is 90 and the other two are 45. And then the 30, 60, 90. And there's a special pattern that goes with it. You guys just need to memorize the pattern. Yeah, sure. If you want to memorize this chart, you're more than welcome to. I'm going to show you where this comes from. I know a lot of you are like, okay, I don't care. But on the unit circle, which we'll get to, I think, next week. But on the unit circle, there are, like, this is 0 and this is 90. So then you have like 45 here. Actually, you have 30 here, 45, 60. So it's like this, like this, like this. All of our angle, our right triangle trig stuff is all based upon the unit circle. So this is where this comes from, where this would be your x value going left and right, and your y value is the up and down. This is your theta right here, so y would be the side that's opposite, and x would be the one that's adjacent. So that's where this chart comes from, and I'll explain that a little more next week when we get to that. But the best thing to do is to memorize the pattern. Does anybody know the pattern? Looking at this, does that look familiar to you? All right, if you think about it, guys, we talked yesterday a little bit about angles and sides. The smallest side is across from the smallest angle, correct? Biggest side is across from the biggest. So does it make sense in a 45, 45, 90, if this angle is 45 and this is 45, the sides that are across from it are the same? Because the angle measure is the same, then the side measure across from it is the same. So what this pattern is saying is when you have a 45, 45, 90, the side that is across from the right angle, the hypotenuse, is the square root of 2 times bigger than the other sides. And I'll do some examples here and then it'll make a little more sense. But the pattern is the legs of the 45, 45, 45, 90 are the same. And then the hypotenuse is the square root of 2 times bigger. In your 30, 60, 90, notice the 1 is across from the 30. Your hypotenuse is twice that size. And then across from the 60 is the square root of 3. So I'll show you how to set up equations to solve that. That's all we're going to do today. So, first example, what kind of a triangle is this? A right triangle. It's a right triangle, good. Is it a 45, 45, 90, or is it a 30, 60, 90? 30, 60, 90. So let's think about what the pattern looks like for a 30, 60, 90. If you want to write this down and say across from the 30, we'll say is 1. Across from the hypotenuse, we'll say is 2, right? And across from the 60, how do I know that's the 60-degree angle? Across from the 60 is the square root of 3. Across from the 60 is the square root of 3. Now, how, if you guys are familiar with this, how were you taught to do this? Anybody? How many of you remember seeing this? How many of you are like, I remember seeing this, I never remembered how to do it? Okay, there's a couple different ways that you could talk about doing this. First of all, what are the sides we know something about? We know something about the hypotenuse, right? And we know something about the one across from 60. Meaning we have a letter present, correct? Do you guys agree with me? All right, so sometimes it can be confusing to use X's because they use X's in the problem. So somebody pick a random letter, not an X or a Y. G, okay, we'll pick a G. So let's think about this as, this is 1G, this is 2G, and this is G square root of 3. Any kind of letter you want, doesn't matter. So now we're going to solve for G. Put it like that. Can I solve for G here? Can I say, does this make sense? X equals G times the square root of 3. Can I solve for G there? Can I get G by itself? Yeah, I could divide both sides by the square root of 3, but does that help me at all? No, okay. So I'm going to come over here and I just say I have 1G. Is there somehow that I could look at that and figure out what G equals? No. Can I do anything with this? Can I set those two things equal to each other? Could I say 2G equals 8? Can I do that? Sure. So then I would divide both sides by 2, and I get G equals what? Get G equals 4. So what did you just do there, guys? You just solved the triangle, because if G equals 4, then you know that 1G over here is how much? This is 4. Well, what's 2G? 8, which we already know. So then what is the value of this? 4 square roots of 3. Perfect. You can pick any letter you want. Gigi picked G because her name is Gigi, right? You will pick any letter. Sometimes people use X's and Y's and then it gets confusing because there's an X in the problem. But if you write out the pattern and just stick a letter to it and then see, okay, wait, is there a side that has a letter and a number that I could set equal to each other? And then you could solve for it. So let's try another one. All right, what kind of triangle is this one? It's a right, correct? And it's a special one. Is it a 45, 45, 90 or a 30, 60, 90? 45, 45, 90. Good. Okay, so let's think about the pattern here. I'm going to write the pattern is the legs are 1 and the hypotenuse is the square root of 2, correct? Yeah? Okay, let's pick a letter. Somebody pick a different letter. W. Okay, so this is 1W, this is 1W, and this is W times the square root of 2, correct? So looking at all of my red, where can I set an equation and say 1W or W something equals a number? Where? Okay, so X equals 1W. Do I know what W equals there? No, okay. Where's there a number? The hypotenuse. Okay, 6 equals W times the square root of 2. Can I get W by itself? Yeah, what would I do? Divide by the square root of 2. Okay, we're getting somewhere now because all the letters by itself, right? There's a number over there. Is that pretty? Can we leave it like that? No, so we're going to rationalize, right? Square root of 2, square root of 2. So when I rationalize this, I get W equals 6 square root of 2 over what number? 2. And then can I fix that a little bit? What does that reduce to? 3 square root of 2. So I found out that my random W is the 3 square root of 2. So now can I figure out what that side length is? What did Sophia tell us here? X equals 1W. So what does X equal, guys? 3 square root of 2. When you guys have these special rights, you are going to have square root of 2 in your answer. You might have a square root of 3 in your answer. There's no decimals. You're not going to have a calculator, so you wouldn't get a decimal anyways. But with special rights, you want to leave things in radical form. So what I did was I took, you have 6 questions for part 2 of your homework. Here's 3 of them. So let's do these 3 together, and then you guys can do 22, 24, and 26. They're exactly the same, just different numbers. But I wanted to kind of go through this again. Because I know at the beginning it's kind of confusing, but if we always have a plan, it's not that bad. If you first write out the problem, then just pick your random letter, and then you're going to set something equal to something. Wherever there's a number, you can set that equal to, and then you can solve. So let's look at this one. 30, 60, 90, or 45, 45, 90? 30, 60, 90. Okay, so let's talk about what we have. It's 1, 2, square root of 3. I like to go ahead and write in the 30 here, just so I remember. The side across from 30 is 1. The side across from 60 is the square root of 3. And the side across from the hypotenuse is 2. Everybody agree? Pick a letter. L. Okay, so this is 1L. I'm going to do it in cursive. This is L square root of 3, and this is 2L. So where do I have, with my pattern, where is there also a number present that I can say, okay, the pattern, 2L square root of 3, whatever, equals a number. The hypotenuse, good. So I'm going to write out 2L equals 9. Divide both sides by 2. Sure, so my L value, my arbitrary L value is 9 over 2. So I just solved this whole triangle. What is this X value that they're looking for? What is 9 over 2? Good. What is the hypotenuse, or this one, if they asked you for it? This would be 9 over 2 square root of 3. That's fine. Mm-hmm.
Why did she simplify?
Simplify where?
9 divided by 2 is 3.
9 divided by 3 is 3.
Yeah.
It's okay. Yeah, I make mistakes like that all the time, so don't worry about it. It's fine. It's C period, last. I get it. My brain's right there with y'all. All right, let's look at the next one. What kind of triangle? 30, 60, 90. Okay, so what's the pattern? Side across from 30 is 1. Across from the hypotenuse is 2. And across from the 60 is the square root of 3. So let me pick a letter. C, okay? So this is 1C, this is 2C, and this is C squared root of 3. Where can I set an equation? 2C equals what? Good. So divide both sides by 2. So what does C equal? 6. Now you guys have solved the whole triangle. What is this side right here? 6. What is this side here? We already know. 6. Oh, yeah. What's the hypotenuse? 12. We already know, right? So what is this side right here? 6 square root of 3. Perfect. I've seen this taught and solved a million different ways. To me, this is the one that kind of just stuck in my brain the easiest. You write out the pattern, pick a rando letter, not X or Y, because that can be confusing. And then there will be one piece of information on one of the sides. You set a little equation and solve for it, then you have the whole triangle. Let's look at 25. 45, 45, 90s are easier. What's the pattern for a 45, 45, 90? Huh? 1, 1, square root of 2. What does X equal, guys? 8. What's the hypotenuse? 8 square root of 2. Good. But let's pick a letter. Let's do the same thing we were just doing a second ago. Pick another letter. A. You say A? Okay, pick A. This is 1A, this is 1A, and this is A squared root of 2. So where do I have a number that I can say, oh, I can make a little equation here? So 1A equals 8. Well, down here, 1A equals what? X. So what does X equal? 8. Over here, 1A equals X, which is 8. So this is just 8 square root of 2. How do we feel? Is that different from the way you guys have seen it before? Okay. Hopefully different sticks in your brain this time. But if it doesn't, you know, we could try something else. But look, you guys have like almost 30 minutes. Do your homework. Get the 9.1 part 1 done if you haven't. The second part is already halfway done. I have too many people turning in late homeworks when I'm giving you time in class to do it. I'm not giving you guys full credit for late homeworks, especially when I give you time in class. So get to work. Then you have time to play on your phones. Yeah? We're good? Okay.